Creating fantasy sports teams can be a fun way to engage in your favorite leagues, while possibly winning some money in the process. But have you ever wondered what's the best way to objectively create the best fantasy team without your personal bias getting in the way? This is the challenge I chose to tackle in our MSC 426 optimization final project. This season, I've been participating in Sportsnet's fantasy hockey competition, where each week I get to choose 6 NHL forwards, 4 defensemen, and 2 goalies that can earn me points if they play well in their games. The competition limits you to how many all-star players you can have by assigning a talent value to each player, which forces you to spend your limited 30 points wisely. And this is exactly what I used to begin formulating our optimization problem. I assigned a variable to each type of player based on the position and assigned talent value, which would indicate how many players should be chosen from each category. For the objective function, I chose to maximize the amount of points received by players historically, which was conveniently provided by Sportsnet in their fantasy points per game statistic. This required me to create a polynomial regression model for each category of player, since we needed a mathematical function, not a discrete list of data points. To finalize our optimization problem, I created an inequality constraint that ensured I didn't spend more than my allotted 30 talent points, and I made sure that each position was filled by utilizing equality constraints. Upper and lower bounds were used so that we didn't have a negative number of players or more players than were allowed for each category. With our optimization problem fully developed, I used Matlab's fmincon and genetic algorithm functions to optimize the problem. The results from our fmincon optimization showed that the solver was able to find the same solution regardless of what initial point I used. However, we can only have integer numbers of players on our team, and so all the results here are rounded values, since fmincon does not allow you to specify the use of only integers. This rounding will simply take us to the closest integer placement, rather than the best nearby solution, which can lead to some untrusted results. Our genetic algorithm results were able to search integer values, which resulted in a much better solution, although it did take a lot more function evaluations. In the end, we can choose the best results from the genetic algorithm and see that it was successfully able to maximize the amount of potential fantasy points on our team. With our variables, we can then fill out a new fantasy team and hopefully win a nice cash prize. Thank you for watching.